Welcome back. I am the Body Whisperer, and I am glad you are here. Before we begin, let us settle in together. Find a comfortable position. Let your arms grow heavy, your legs, your shoulders. Take a slow breath in and let it go. One more. In and release. Good. Now, while you rest here doing nothing at all, something quiet is happening inside you. Your body is working. It always is. Every hour of every day, without ever asking for thanks. I want you to get to know it a little better, to listen to it, to feel it, to appreciate it. Because the more you understand the quiet world beneath your skin, the more at home you feel inside your own body. So, come and meet Glucagon Gerald, one small part of you that keeps working through the night while you sleep. This is the story of 2 hours of Pancreas and Glucagon facts to fall asleep to. There is nothing you need to do now, nowhere to be, nothing to figure out. Just breathe, close your eyes if you have not already, and let us begin. Here is something almost nobody knows. Right now, while you are lying here drifting towards sleep, a hormone is quietly clocking in for the night shift. You have probably heard of insulin. Most people have. Insulin is the one that shows up after every meal, knocking on cell doors, delivering glucose, keeping the whole system from flooding. Insulin gets all the press. It is the one doctors talk about at every checkup. But insulin has a counterpart, a partner on the opposite end of the same dial, and almost nobody knows his name. His name is Glucagon Gerald, and his shift starts right about now. Gerald is made in the pancreas, not the whole pancreas, a very specific, very small neighborhood inside it. The pancreas, for those who have never properly met it, is a pale, smooth, tadpole-shaped organ tucked just behind the stomach. It runs about 6 inches long, tapers from a wide head to a blunt tail, and it does 2 enormous jobs simultaneously. It makes digestive enzymes that break down your food, and it makes hormones that control your blood sugar. The man in charge of both operations is Pancreas Pete, calm, dependable, never off the clock, a dual-role manager who has not had a quiet afternoon since the first meal you ever ate. Deep inside Pete's tissue, there are tiny islands, thousands of them. Each one is called an islet of Langerhans, named for the German medical student who first described them in 1869. These islets are the blood sugar command centers. They are where insulin is made, in the beta cells, and where glucagon is made, right next door, in the alpha cells. Same organ, same islet, reading the same blood, doing opposite jobs. That is what Pete means when he says it, quietly, at the end of every shift handoff. Same organ, opposite shift. Insulin Ivan works days. When you eat, blood glucose rises, Ivan gets the call, and he goes sprinting through the bloodstream, knocking on every cell door he can find: muscle cells, fat cells, liver cells, delivering glucose like a man with far too many packages and not enough time. Ivan is compact and efficient, a little hexagonal crystal of a hormone, blue-gray and businesslike. When cells answer his knock, glucose flows in, blood sugar comes down, and everybody is happy. Ivan's catchphrase is that the rules are simple, and when everyone follows them, they are. But here's the thing: you are not eating anymore. The kitchen is closed. The last meal is hours behind you now, and the glucose that arrived with it has already been delivered, stored, or burned. Blood glucose is doing what it always does when food stops coming in. It is beginning very slowly, very quietly, to fall. And that is where Gerald's night begins. Glucagon Gerald is an alpha cell product, born in those same islets, raised right next door to Ivan, but built for a completely different purpose. Where Ivan's job is to lower blood glucose, Gerald's job is to raise it, to protect the floor, to make sure that while your brain is running its nighttime housekeeping and your heart is keeping its steady rhythm and your kidneys are quietly filtering, all of them burning glucose, all of them needing a steady supply, the blood never runs dry. Gerald is not a flashy hormone. He does not generate much conversation at dinner parties. He is calm, competent, and quietly tired in the way that anyone is tired when they have been working the overnight emergency desk long enough to have seen every kind of 3 a.m. He does not panic when glucose dips. He has seen it dip 1,000 times. He knows exactly what to do. His mission every single night is the same: hold the line. He has exactly 2 tools to do it with. The first is a process called glycogenolysis. That word is longer than it needs to be, so here's what it actually means. Your liver has been storing glucose all day, packing it into a compact branch storage molecule called glycogen. Glycogen is glucose in its saved form, the body's version of a pantry, stocked and ready. Glycogenolysis is the act of opening that pantry and releasing what is inside, breaking glycogen back down into free glucose and sending it into the blood. The second tool is gluconeogenesis. This one is even more remarkable. When the pantry starts running low, Gerald does not simply wait for morning. He calls for new glucose to be built from scratch, assembled from raw materials that have nothing to do with the carbohydrates you ate for dinner. Amino acids, lactate, glycerol. The liver takes these precursors and manufactures fresh glucose, molecule by molecule, to keep the blood supplied through the long hours before breakfast. Both of those operations happen in one place, the liver. And that is where Gerald is headed now, radio in hand, walking the long, quiet corridor of the bloodstream toward the largest organ in the body's abdomen. Lisa is already at her desk. She is always already at her desk. She manages hepatic glucose production, deciding every moment of every night whether the liver stores glucose or releases it. She runs a tight department. When Gerald calls in a low, she does not need it explained. But there is something Gerald has not told Lisa yet. Something about the particular chemistry of this night that is going to make his job a little more complicated than usual. The liver is reading a ratio. Not just one hormone, a ratio. And right now, that ratio is shifting. The ratio is shifting. That phrase deserves a moment, because most people, when they think about blood sugar at all, think about a single hormone doing a single job. Insulin goes up, sugar goes down. Simple enough, but the body does not actually work that way. It does not respond to one hormone at a time like a light switch. It reads a relationship, a proportion, a balance between two signals arriving from the same small neighborhood in the pancreas. Think of it like a thermostat dial, not a button you press, but a dial you turn. On one end, insulin Ivan, pushing glucose into storage, telling the liver to lock the reserves away. On the other end, Glucagon Gerald, pulling the dial the other direction, telling the liver to open the doors and let glucose back out. The liver does not obey whichever one is louder in absolute terms. It reads where the dial is pointing. And right now, as the hours of sleep deepen and no food has arrived, the dial is turning slowly, steadily toward Gerald. Ivan has quieted down. When you last ate, Ivan was busy, knocking on cell doors, delivering glucose parcels, signaling the liver to tuck extra sugar away as glycogen for later. He was everywhere at once, the way he always is after a meal. But meals end, and as glucose from that meal gets absorbed and distributed, Ivan's signal fades. There is less glucose coming in, so there is less need for Ivan to shout. His levels drop, his side of the dial loses weight. And so, almost automatically, Gerald's side of the dial gets heavier. This is what makes the liver so remarkable. And now is a good moment to meet the liver properly. Liver Lisa runs one of the most demanding operations in the entire body. She processes what you drink, regulates what you burn, stores the vitamins you forget to think about, filters the blood that passes through her constantly, and handles dozens of chemical jobs at the same time around the clock. And on top of all that, she is the body's primary glucose factory and warehouse. When Gerald radios in, Lisa is already awake. She is always already awake. She was running the numbers before the call came in. What Lisa reads specifically is not Gerald's signal alone. The proportion of glucagon to insulin arriving at her receptors tells her, with quiet precision, what mode to operate in. High insulin relative to glucagon, store glucose, build glycogen, lock it up. Low insulin, rising glucagon. The situation unfolding right now in these quiet hours of sleep. Release glucose, open the reserves, keep the blood supplied. Lisa does not require drama to act. She hears the ratio shift, and she shifts with it. No alarm, no emergency announcement, just a change in operations, as smooth as a loading dock switching from receiving to dispatch. Here is the thing that takes people by surprise when they first hear it. The liver has two ways to send glucose out. The first is to break apart what it has already stored. The liver holds glycogen, a dense branched chain of glucose molecules packed together like a compact warehouse of ready parcels. When Lisa gets the signal, she can break those chains apart and release individual glucose units directly into the blood. That process is called glycogenolysis, and the one who runs that operation is already at his desk. Glucagon Gerald has been the night shift logistics manager of the liver's glucose warehouse for longer than most people have been aware that the liver's glucose warehouse exists. He is, to put it plainly, very good at his job. When Gerald's signal reaches Lisa and Lisa passes it along, Gary does not stretch, does not check the clock, does not ask for clarification. The shipment is ready. It was always going to be ready. That is what Gary does. Glucose Gloria, the 6-carbon sugar that Gerald's entire career is dedicated to protecting, is what comes out the other end of Gary's operation. Small, bright, eager to be useful, Gloria moves from the liver's reserves into the bloodstream and begins making her way toward the brain and the muscles that need her. She is not dramatic about any of this. She simply gets to work. But here is where the story gets more interesting. Gary's warehouse is not unlimited. Glycogen stores in the liver are genuinely finite. A well-fed liver can hold a meaningful reserve, enough to keep blood glucose steady for a number of hours. But a long fast, a night of deep sleep, an unusual stretch without eating, and that reserve begins to draw down. Gary ships and ships, and the warehouse gets lighter. This is why Gerald has a second tool. When the glycogen starts to thin, the liver does not simply run out and give up. It switches to manufacturing. It begins building new glucose from raw materials, amino acids, lactate, glycerol, molecules that were not glucose to begin with, reassembled into glucose from scratch. That process is called gluconeogenesis, which is simply a long way of saying the body makes new sugar when the stored supply runs low. Gluconeogenesis is slower than glycogenolysis. It takes more steps. It asks more of Lisa. But it is the reason that a healthy body can fast through an entire night of sleep and wake with blood glucose still in balance. Not because the supply is unlimited, but because the factory never fully closes. And Gerald is the one who keeps the factory running. The dial is still turning, and the night is still young. The dial is still turning, and the night is still young. Now here is something that surprises almost everyone who hears it for the first time. Most people think of Glucagon Gerald as the low blood sugar hormone, the one who shows up when the tank is running dry. And that is absolutely true, but it is not the whole story. Because Gerald does not only respond to falling glucose, he also responds to something else entirely, something you might not expect to find on his radar: protein. Specifically, rising amino acids in the blood. Amino acids are what you get when your body breaks down protein from food, from a chicken breast, a handful of almonds, a late dinner of steak and eggs. Protein arrives at the gut, gets dismantled piece by piece, and those individual amino acid building blocks spill into the bloodstream. And when they do, the alpha cells of the islets of Langerhans notice. Gerald notices, and he gets to work. Now, why would that be? Why would Gerald care about protein? Here's the thing. Imagine you just ate a meal that was almost entirely protein. Very low carbohydrate. Maybe you skip the bread, skip the rice. Just the steak, just the eggs. Insulin Ivan gets a small signal. There is not much sugar arriving to store, but a modest insulin release still happens. And here is the problem with that. If Ivan quietly puts in even a small shift, he is still nudging blood glucose downward. And if there is not much incoming sugar to counterbalance him, blood glucose could fall a little too far. Gerald steps in to prevent exactly that. When amino acids rise, Gerald rises too, right alongside Ivan, not instead of him. The two hormones go up together in response to a protein-rich meal. Gerald is essentially watching Ivan's back, making sure that whatever modest glucose-lowering Ivan does not tip the body into a shortage. It is a safeguard built into the system. A quiet correction mechanism that keeps things level even when the meal is heavier on protein than on carbohydrate. Deep in the liver, Lisa, the body's most tireless biochemist, the organ responsible for producing glucose, processing everything that arrives from the gut, and keeping the blood chemistry on an even keel, Lisa reads both signals simultaneously. She reads the amino acids. She reads Gerald's message. And she understands what the body is asking for. Not a big glucose release, not an emergency response, just a maintenance mode, a steady hand. Liver Lisa, it should be said, does not waste words explaining this. She simply does it. That is her way. So, the next time someone tells you that protein does not affect blood sugar, you can offer a gentle amendment. Protein does not raise blood glucose the way a bowl of rice does. That part is true. But protein absolutely engages the hormonal system. Gerald is in the conversation. The body is paying attention. There is a second surprise attached to this one, and it is worth slowing down to appreciate. Glucagon Gerald's job is not only about sugar. Most people, if they have heard of glucagon at all, picture it as a single-purpose tool. Low blood sugar arrives. Gerald releases glucose from the liver. Problem solved. That is the textbook summary. It is not wrong, but it leaves out something rather remarkable. Gerald also signals the body to release stored fat. The technical term is lipolysis. It means the breakdown of fat stored in adipose tissue, in the body's fat deposits, into fatty acids and glycerol, which can then be used for fuel. When Gerald is active, he does not just open the liver's glucose warehouse. He also quietly radios the fat stores and says, "We may need backup fuel here. Start releasing." And the fat stores listen. This is important because it reveals something about what Gerald is really doing through the night. He is not simply a one-trick glucose dispenser. He is an energy mobilizer. His job is to make sure the brain, the heart, the muscles, every cell that is quietly humming through the sleeping hours has access to fuel in whatever form is available and appropriate. Sometimes that fuel is glucose, sometimes it is fatty acids. Often it is both, running in parallel, each tissue drawing on what it handles best. The brain, for its part, is picky. It runs almost exclusively on glucose under normal conditions, and Gerald knows this. The brain is the priority. Glucose Gloria, the simple 6-carbon molecule that is the body's most immediate energy currency, the one who just wants to be useful, the one who gets a little anxious when she cannot get where she needs to go. Gloria has a standing priority pass to the brain. Gerald's gluconeogenesis keeps that pass valid through the long, foodless hours before morning. The fat release is for everyone else. The muscles, the heart, the liver itself. They can run on fatty acids quite happily, and doing so frees up glucose for the organs that cannot switch fuels so easily. So Gerald is running 2 parallel operations at once. Glucose from the liver, fat from the fat stores. A coordinated logistics effort across multiple depots, all to keep the sleeping body fueled without a single bite of food. Glycogen Gary, over in his liver warehouse, is already deep into the shipment. The amber gold branches of his glycogen reserves are being clipped unit by unit, each one converted back to glucose and sent out into the blood. Gary does not require motivation. Gary does not require reminders. Gary has been at this desk since before you sat down for dinner. But Gary's reserves are not infinite. And that fact, quiet, patient, inevitable, is where this night's real challenge begins to take shape. Gary has been at his desk since the body last ate. That could be a few hours ago, could be longer. He does not complain about the hours, he simply ships. But here is the thing about Gary's warehouse. It is not a bottomless supply. The liver can hold enough glycogen to keep the brain and the rest of the body fueled for somewhere between 8 and 12 hours of fasting. Roughly, give or take, depending on how much was stored to begin with, how active the day was, how big the last meal happened to be. The numbers shift, the principle does not. The shelf is finite, and the shelf is slowly emptying. Gerald knows this. He has always known this. It is the central fact of his working life. So while Gary is still shipping, calmly, efficiently, one glucose parcel at a time, Gerald has already begun preparing for the moment when Gary's inventory runs thin. Because when that moment comes, the body cannot simply pause and wait for breakfast. The brain does not pause. The brain is running right now, steady and quiet, drawing on glucose the way a lamp draws on current. It does not tolerate interruption well, and so Gerald turns to his second tool, gluconeogenesis. The word is a mouthful, but the idea is almost elegant once you see it. Glucone, sugar. Neo, new. Genesis, making. New sugar, made from scratch, not from stored glycogen. From raw materials the body already has lying around. What raw materials exactly? This is where it gets interesting. The liver. Liver Lisa, who is already running 3 other operations at the same moment Gerald radios in, can take certain amino acids, the building blocks left over from protein the body has broken down, and convert them into glucose. She can take lactate, the byproduct of muscles working hard, and cycle it back into usable sugar. She can take glycerol, the backbone left behind when fat breaks down, and thread that into the glucose-making process as well. Lisa, it should be said, is not a simple operation. She is a large, two-lobed structure settled in the upper right of the abdomen, warm chestnut brown, smooth, slightly wedge-shaped, and she is the body's most metabolically demanding organ by a significant margin. She filters blood, she stores vitamins, she processes every medication that passes through. She handles alcohol, she makes proteins, she manufactures bile. And somewhere in the middle of all of that, she also runs a 24-hour glucose production facility that never quite closes. When Gerald radios her at this hour, she is not surprised. Already running the numbers, she tells him. Short sentences, no unnecessary words. That is Lisa. Gluconeogenesis is not as fast as glycogenolysis. Gary can ship a glucose parcel in moments. It is pre-made, pre-packaged, sitting right there. Gluconeogenesis is more like a small batch manufacturing run. The raw materials have to be gathered. The chemical steps have to proceed in order. The process runs, but it runs at its own pace. This is why the body does not simply skip to gluconeogenesis from the start. It runs Gary's warehouse first because Gary is faster, and then shifts the balance toward new production as the hours deepen. What Gerald is managing then is a transition, a handoff from stored supply to live production, from Gary's pre-made parcels to Lisa's ongoing assembly line. And the signal that controls that handoff is the same signal that has been driving everything else in this story, the ratio of glucagon to insulin. As Ivan rests, and by this point in the night, Ivan is genuinely quiet, there is very little insulin circulating. Gerald's side of that ratio climbs. And when that ratio rises high enough, Lisa reads it as a clear instruction. Stop storing, start making. Keep the glucose moving outward. Keep Gloria circulating. Gloria, for her part, is doing her job. She is traveling through the bloodstream, crossing into cells where she is needed, keeping the brain's quiet electrical work ticking over. She does not require fanfare. She just wants to be let in. But she needs to exist in order to be let in. She needs Gerald and Gary and Lisa all working in sequence to make sure that she does not dip so low that the quiet signals in the brain begin to shift. There is a kind of poetry in this, if you are willing to see it. The body, hours into a fast, is not struggling. It is running exactly the system it was built to run. Gerald is not a backup plan. He is the plan. The overnight fast. And this is a real, precise thing. The period when no food is entering the body and the liver must sustain blood sugar on its own is a condition the human body has handled every single night for as long as human beings have existed. Gerald has been doing this job for a very long time. Long before anyone had words for glycogenolysis or gluconeogenesis. Long before anyone knew what a glucagon molecule looked like. He did the job. And now, with Gary's shelves slowly thinning and Lisa's manufacturing line beginning to spin up in earnest, the night is settling into its quieter rhythm. Not the fast drama of the first hour after a meal. Something slower, something more sustained. Gerald settles into his shift. There is still a long stretch of darkness before morning. And the next challenge, patient, chemical, particular, is already taking shape in the liver's back rooms. There is still a long stretch of darkness before morning. And the next challenge, patient, chemical, particular, is already taking shape in the liver's back rooms. Here is something most people never think about. Gluconeogenesis, that slow, deliberate process of building new glucose from scratch, does not run on air. It needs raw material. It needs something to start with. And the question that shapes the next few hours of Gerald's shift is simply this: where does that raw material come from? The answer, it turns out, is from nearly everywhere. Liver Lisa, that warm chestnut brown two-lobed manager who runs the body's most demanding department, knows this well. She has a short list, and she reads it the same way every time. 3 main suppliers: amino acids, lactate, glycerol. Each one arrives at her dock by a different route. Each one gets converted, step by careful step, into glucose. Let's take them one at a time, the way Lisa would. Not all of them. The body is not cannibalizing muscle at random. Certain amino acids, particularly alanine and glutamine, are what biochemists call glucogenic, meaning the body can strip away their nitrogen and reshape the carbon skeleton into a glucose precursor. Alanine, in particular, is the workhorse. Muscle cells constantly produce it, even during a quiet fast, and they ship it through the bloodstream to Lisa's dock. She receives it, removes the nitrogen, which eventually leaves the body as urea, and takes the remaining carbon frame and builds it into glucose. It is a longer route than breaking down glycogen, but it is a route that does not run out the same way Gary's reserves do. Gary, by the way, is still at his desk in the liver's glycogen warehouse. He has been noting, with the quiet attention of someone who has managed inventory for a very long time, that his shelves are not as full as they were at midnight. He does not report this as a crisis. He reports it the way a good warehouse manager would, accurately and early. Gerald receives the update and files it without comment. Lactate is the second supplier. Here is a piece of biology that surprises people the first time they hear it. When muscles work, even the gentle, low-level work of staying alive through the night, the work of breathing and keeping the heart beating, they produce lactate as a byproduct. That lactate does not simply sit in the bloodstream as waste. It circulates to the liver, where Lisa converts it back into glucose. That glucose can then return to the muscles or travel to the brain. The whole loop has a name: the Cori cycle. It is one of the quieter elegances of human metabolism. Fuel is converted to byproduct. Byproduct is converted back to fuel, and the loop keeps turning through the long hours of a fast. Glycerol, is the third supplier, and this one connects back to something Gerald set in motion earlier in the shift. Remember that Gerald does not only signal the liver, he also reaches adipose tissue, fat stores, and stimulates lipolysis, the release of stored fat. When a fat molecule breaks down, it splits into two parts, fatty acids and glycerol. The fatty acids go to the liver and other tissues to be burned directly for energy. But the glycerol, that small 3-carbon backbone, travels to the liver as well, where Lisa adds it to her gluconeogenesis production line. So fat breakdown feeds glucose production. It is literally what happens. Gerald opens the fat reserve, and part of that reserve becomes the raw material for new glucose. All of this is running quietly while you sleep. Lisa is receiving shipments. The production line is moving. Gerald is maintaining the signal that keeps it all going. And the glucagon to insulin ratio, that dial the liver reads more carefully than any clock, is holding steady on Gerald's side because Ivan is still quiet, still resting, still waiting for a meal that is hours away. This is what a managed fast looks like from the inside. Not deprivation, not crisis, organization. Gerald has learned over a long career of 3 a.m. shifts that organization is not the same as immunity. There are conditions that can complicate the picture. There are nights when the liver's ability to run gluconeogenesis is quietly, chemically compromised, not by disease, not by dramatic failure, but by something as ordinary as a glass of wine with dinner. This is where Liver Lisa's other workload becomes relevant. Because Lisa does not only make glucose, she processes nearly everything that enters the bloodstream. Medications, toxins, and alcohol, it turns out, changes the internal chemistry of the liver in a way that has a very specific effect on what Lisa can do through the night. The mechanism is not complicated, but it is worth understanding slowly. When the liver breaks down alcohol, that process consumes a molecule called NAD+, a critical chemical helper Lisa uses to run gluconeogenesis. As NAD+ gets used up, the ratio inside the liver shifts, less NAD+, more of its reduced form, NADH. And when that ratio tips, Lisa finds that several of the chemical steps in gluconeogenesis simply slow down. The raw materials are still arriving, but the machinery that converts them is running at reduced capacity. Glucose Gloria, that cheerful golden hexagonal molecule who just wants to be useful, has been moving through the bloodstream at a steady pace. But through the hours after a drink, that pace can drift slightly lower than it otherwise would. Not a cliff, a slow drift, the kind that the body's counter-regulatory system is designed to catch. And cortisol Carl is already aware. He is always aware. He has been watching the numbers with the particular attention of someone who has learned never to be caught off guard. Carl had been watching the way a careful deputy watches, not hovering, not intruding, just present, his hand resting near the dispatch radio, not reaching for it yet. And here is something worth understanding about how the body handles a falling blood sugar. It does not rely on one hormone. It never has. The body is too wise for single points of failure. Glucagon Gerald is the first responder. That part you already know. When glucose Gloria begins to drift quiet, when her signal gets thinner and the cells start to notice the silence, Gerald is the one who picks up first. He is the one with the fastest line to the liver. He is the one Lisa is always listening for. But Gerald is not alone on the counter-regulatory team. That is the phrase the body uses if the body used phrases. Counter-regulatory. It means the system that pushes back against a falling blood sugar. The counter to the fall. The regulation that holds the floor. Gerald leads that team, but when the low runs deeper, or when it runs longer, backup arrives. Cortisol Carl is one of them. Now, Carl has a complicated reputation. He has spent years being described in terms of traffic jams and deadlines, and the particular kind of stress that makes your shoulders creep toward your ears. That version of Carl is real, but it is only one side of the story. Carl also has a perfectly legitimate night job, a useful one, a physiologically respectable one. When blood glucose falls far enough that Gerald's first response, Gary's glycogen shipments, Lisa's gluconeogenesis line, is not quite enough on its own, Carl steps in as a counter-regulatory deputy. His role in that moment is not dramatic. He helps the liver maintain glucose output. He helps mobilize stored fuels. He supports the operation that Gerald already has running. He does not take over. He reinforces. Carl, for his part, would simply like people to know this about him. He has legitimate uses. He was designed for moments exactly like this one. He would prefer not to be discussed, only in the context of difficult Mondays. So when Carl appears in this story, and he will, quietly, in the hours before the light begins to change, understand that his appearance is not a sign of crisis. It is the body's normal architecture showing itself. It is the backup team doing what backup teams exist to do. There is also epinephrine, adrenaline if you prefer the older name. When a low deepens significantly, epinephrine rises too, accelerating glycogen breakdown, suppressing insulin's activity, pushing more glucose into circulation, fast and forceful, the way epinephrine tends to be. But during an ordinary overnight fast, epinephrine stays mostly quiet. Gerald handles the routine. Carl provides quiet reinforcement if the curve dips a little further than usual. Epinephrine is there if the situation escalates past that. Think of it like a tiered response. Gerald manages the night. Carl is the deputy. Epinephrine is the emergency override. And the remarkable thing, the thing that tends to surprise people when they first understand it, is how rarely the body needs to escalate past the first tier. Gerald's work is that consistent. The overnight fast in a healthy system is not a crisis. It is a managed operation, running on schedule, hour by quiet hour. Gloria, for her part, had settled into her own rhythm. She was quieter than she would be after a meal, naturally so, in the fasting hours, but not dangerously quiet. She was moving steadily through the bloodstream, delivering fuel to the brain, keeping the neurons running their slow overnight housekeeping. She was doing her job the way she always does her job, without fuss, without ceremony, just steadily showing up wherever she was needed. She had not signaled any alarm, not yet. The curve was holding. Gerald had seen enough nights to read that curve without numbers. He read it the way an experienced ship's captain reads the water. Not by looking at a gauge, but by feel, by the quality of the signal coming in, by the tiny shifts in chemical language that he had been interpreting since long before anyone thought to give him a name. The islets of Langerhans were quiet. The beta cells, Ivan's territory, had nothing to do right now. No meal incoming, no glucose spike to respond to. Ivan himself was at the back of the break room, half asleep in a chair, his delivery clipboard on the table beside him. His hexagonal frame was relaxed in a way it almost never was during the day. He would not admit, if you asked him, that he found the night shifts peaceful, but he did. Gerald was aware of Ivan's silence. That silence was data, the low glucagon to insulin ratio that Lisa reads as a storage signal. That ratio had flipped hours ago. Ivan was quiet. Gerald's side of the dial was up. Lisa was running the release operation, steady and unhurried, the way she always ran the operations she had run 10,000 times before. "We have order here," she had said at the beginning of the shift. She had not needed to say it again. The clock moved the way it does in the hours that most people sleep through. Slowly and not unpleasantly, and with the particular quality of stillness that belongs only to a body at rest and a system doing its quiet, essential work. Somewhere in the liver, a fresh glucose molecule was being assembled, lactate arriving from the muscles, alanine coming in from the amino acid pool, glycerol from the fat reserves, where Gerald's earlier lipolysis signal was still producing results. Lisa received each one without ceremony. She knew what to do with it. She had always known what to do with it. And Gerald, standing at his post in the islet, felt the night settle around him like a familiar coat. And so the night moved along, the way all good nights do, quietly, without announcement, one thing following the next in a sequence so practiced it barely made a sound. Gerald stood at his post inside the islet of Langerhans, that small community of specialized cells tucked inside the pancreas. And here is something worth pausing on, because most explanations skip right past it. How does Gerald actually know when to act? Not in a general sense. Not blood sugar falls, glucagon rises. That is the headline, and headlines leave out the interesting part. The interesting part is what happens inside the alpha cell itself. Because Gerald is not watching a dashboard somewhere. He is not checking a monitor. He is the sensor. He is the response. The alpha cell that makes him is itself reading the blood glucose level that flows past it. And when that level dips, the cell changes. Here's the thing about alpha cells. They are electrically excitable. That phrase sounds complicated, but it just means this. The cell has a resting state, and it can be pushed out of that resting state by changes in its environment. When blood glucose falls, the chemistry inside the alpha cell shifts. Ion channels, Tiny protein doors in the cell membrane open and close in a different pattern. The cell's electrical charge changes, and that change is the trigger. That is what sets off the release of Gerald into the bloodstream. Think of it like a spring-loaded door. Low glucose is the thing that releases the latch. And Gerald walks through. Now here's where it gets a little more layered and a little more interesting. Because the alpha cell does not live alone in the islet. It lives right next door to the beta cell, Ivan's home. And those two cell types are in constant conversation, even when neither is speaking out loud. They communicate through tiny chemical signals that pass between them through the shared space of the islet. Insulin itself, at high concentrations, appears to suppress glucagon release. So when Ivan is busy, when he is out making deliveries, when blood glucose is high and insulin is flowing, that signal drifts over to the alpha cell and says, "Stay quiet." Not yet. And when Ivan quiets, that suppression lifts. The alpha cell is, in a sense, waiting for Ivan to step back before it steps forward. Two ends of one dial. Pancreas Pete had always described it that way, and standing here in the small hours, it was hard to argue with him. What nobody tells you is how elegant this arrangement is. The hormones are not sent from some central command post that looks at a number and decides what to do. The cells themselves read the environment directly. The alpha cell reads glucose. It reads the presence or absence of insulin. It reads amino acids arriving in the blood after a meal. It integrates all of that at once, locally, without waiting for instructions from above. The pancreas is not a bureaucracy. It is a town where the residents manage their own affairs and do so, by and large, with surprising competence. Gerald appreciated this. He had worked this shift long enough to know that the system's strength was exactly that distributed quality. Nothing depended on one signal. Nothing depended on one cell getting it exactly right. The islet as a whole found its balance the way a conversation finds its rhythm. Each voice responsive to the others. No single voice in charge. By this point in the night, with the last meal several hours behind, that balance had settled into a familiar configuration. Genuinely quiet, not suppressed, not overwhelmed, just resting at a low baseline, because there was no flood of new glucose coming in to require his attention. And with Ivan quiet, Gerald's side of the ratio had risen, not because Gerald had suddenly increased his volume, but because Ivan had turned his down. The ratio shifted, and the liver was listening. Liver Lisa, across the bloodstream, had registered the change. She was always registering it. That was essentially her entire job on this shift. Read the ratio, adjust the output, keep Gloria circulating at a steady level. Lisa ran 2 floors of operations simultaneously. Glycogen release upstairs and gluconeogenesis running steadily in the background. She did not require updates. She read the signal in real time and responded accordingly. Gloria herself was doing what she always did when things were running correctly. She was moving. Brain to muscle to organ and back through the blood, present where she was needed, drawn down quietly by tissues that depend on her through every sleeping hour. She was not anxious. She was not piling up in places she should not be. She was, for this particular moment, simply in balance, which was to her the most satisfying condition possible. He was the kind of responder who paid attention to the spaces between emergencies, the quiet patches where everything was simply working. There was a satisfaction in it that people rarely gave this work credit for. The crisis response was visible. The steady maintenance, the gentle titration of release that kept Gloria level from hour to hour while the rest of the body slept, that was invisible. It happened and left no record except the absence of a problem. That was, Gerald had long since decided, fine with him. And somewhere deeper in the chemistry of things, in the electrical whisper of the alpha cell, and the quiet ratio the liver was reading, the body continued its unhurried arithmetic. The night held steady, and somewhere deeper in the chemistry of things, in the electrical whisper of the alpha cell, and the quiet ratio the liver was reading, the body continued its unhurried arithmetic. Now here is something that most people never stop to wonder about. Glucagon Gerald does not simply drift out into the general circulation the way a radio broadcast scatters in every direction. He has a very specific address. The first stop, the primary destination, the place he is aimed at before anywhere else, is the liver. And the reason for that is geography. The pancreas sits tucked in close to the liver. Blood leaving the pancreas does not take a long tour of the body before getting to work. It travels a short direct route through a vessel called the portal vein, which empties almost immediately into the liver. So Gerald, freshly released from the alpha cells, arrives at liver Lisa's door in very high concentration, far higher than anywhere else in the body. By the time that same blood has looped through the lungs and the heart and come back around to the muscles and the brain, the concentration has diluted considerably. Liver Lisa, for her part, is entirely unsurprised by this arrangement. She has been receiving deliveries through the portal vein her entire career. Here is why that geography matters. The liver is the target organ for glucagon's most urgent work. Glycogenolysis, the breaking down of stored glycogen, happens here. Gluconeogenesis, the building of new glucose, happens here. These are not tasks that need to run in every tissue of the body simultaneously. They need to run in one highly organized facility, and that facility receives the signal first and strongest. Think of it like a letter addressed to a specific department, rather than broadcast through a loudspeaker. The loudspeaker approach would be chaotic. Your muscle cells and your kidney cells and your heart cells do not need to receive a full-strength glucagon alarm every time blood sugar dips a little low through the night. The liver handles it. The liver was built to handle it. So the address on the envelope reads, Portal Vein, Liver, Urgent. And Lisa opens it before anyone else even knows it was sent. Glucagon Gerald, it should be said, is not without effect elsewhere in the body. The heart has receptors for glucagon. Adipose tissue, the body's fat stores, responds to it, which is how Gerald calls on lipolysis as a parallel fuel source, as we have already seen. But those responses are quieter, working at lower concentrations. The liver's response is the dominant one. The liver is the loudest room in the building, and inside that room, Lisa is doing something elegant. When Gerald's signal arrives, when the ratio of glucagon to insulin tips in Gerald's favor, Lisa does not simply flip a switch. She begins a cascade of molecular events. Gerald binds to a receptor on the surface of a liver cell. That receptor activates a signaling molecule called adenylyl cyclase. Adenylyl cyclase produces something called cyclic AMP, a small, fast messenger that ripples through the inside of the cell like a stone dropped in still water. Cyclic AMP then activates a protein called protein kinase A. And protein kinase A, and here is where the elegance is, does two things at once. It activates the enzymes that break glycogen down, and it inactivates the enzymes that build glycogen up. The same cascade. One signal, two coordinated switches thrown in opposite directions at the same moment. The body does not waste energy running the storage machine and the release machine simultaneously. When Gerald gives the signal, Lisa does not just start the release line, she pauses the storage line. It is efficient in the way that only something that has been running for hundreds of millions of years of evolution has learned to be efficient. Glycerol Gary, in his warehouse deeper in the liver's architecture, had been feeling this for hours. The branching arms of the glycogen stores, those amber gold chains he tends so carefully, were shortening at the tips, parcel by parcel, not depleted, not anywhere close to empty, but reading lower than they had at midnight. Gary kept his dispatch notes the way he always did, without drama, without alarm, with the calm of a man who has seen the reserves draw down and refill more times than he could count. Shipment ready, he noted in his quiet internal ledger. Shipment ongoing. And Lisa, running her gluconeogenesis line in parallel, was feeding new glucose into the same output. Amino acids arriving, lactate cycling back in through the Cori route, glycerol coming up from the fat stores. The two streams, the old reserves and the freshly built supply, met at the same output, and what flowed out was steady, measured glucose, moving into the blood at exactly the pace the brain and the other quiet sleepers of the body required. Glucose Gloria, who had grown a little subdued in the hours since the last meal, felt the resupply the way you feel a warm current shift beneath you in deep water. She did not announce it. She simply brightened a little, steadied, and kept moving. The portal vein had done its work. The cascade had run. Cyclic AMP had delivered its message. Protein kinase A had thrown its two switches, and the liver's most important overnight accounting was, for now, in balance. The arithmetic continued, and completely invisible to the person sleeping above it all, whose only job in this moment was exactly what they were already doing. Precise and completely invisible to the person sleeping above it all, whose only job in this moment was exactly what they were already doing. Now, here is the part of the story that most people never hear. The part that happens not in the liver, not in the pancreas, but in the blood itself, in the quiet, dark, traveling substance that connects every character in this story to every other. Glucose Gloria had been moving through the bloodstream all evening. Energetic, purposeful, knocking on cell doors, slipping through membranes, fueling the brain's endless low murmur of nighttime processing. She is the body's most immediate fuel, a simple 6-carbon ring of sugar, warm and golden, the thing every cell in the building has been waiting for. When she is plentiful, the whole system hums. When she begins to thin, the system notices. And here's the thing, it notices long before anything feels wrong. Gloria had been drifting downward through the small hours, not dramatically, not alarmingly. Just the gentle, steady descent that every overnight fast produces as cells draw on the available supply and the last meal grows more distant. She was quieter now than she had been at dinner. Less abundant. Still present, still working, but present in the way a voice gets quieter when a room starts to empty. The brain was the first to register the shift. Not consciously, the sleeping person above had no idea. But the hypothalamus, that ancient cluster of cells deep in the brain that monitors the body's internal state, began to read the change. The hypothalamus does not sleep. It watches. It receives constant signals about blood glucose, body temperature, osmolarity, hormone levels. It is the body's overnight dispatcher, and it had been watching Gloria's quiet drift for some time. What nobody tells you is that the response to a falling blood glucose is not a single alarm. It is more like a series of quiet conversations that happen in sequence, each one more urgent than the last, each one involving a different set of characters. The first conversation had already happened. That was Gerald's conversation with Liver Lisa, the glucagon signal, the cascade through cyclic AMP and protein kinase A, the simultaneous opening of glycogen stores, and the acceleration of the gluconeogenesis line. That conversation had been running for hours already. Gerald had been keeping Gloria from falling further, holding the floor steady while the fast continued. But there is a second conversation, and this one involves a different kind of sensing entirely. Deep in the walls of the carotid arteries, the great vessels that carry blood up to the brain, there are specialized sensors called chemoreceptors. Their primary job is monitoring oxygen and carbon dioxide, the chemistry of breathing. But they also respond to glucose. And in the tissues of the hypothalamus itself, there are glucose-sensitive neurons, cells that change their firing rate based on how much glucose is available in the fluid around them. When Gloria's presence thins, these neurons notice. They send signals downstream, and those downstream signals are part of what keeps Gerald calibrated, part of what keeps the counter-regulatory response proportional to the actual degree of the drift. Turns out the body runs its own early warning system, entirely below the level of thought. Gloria, for her part, was not panicking. That is not her nature. She just got quieter, the way she always does in the small hours, and she trusted that the people around her knew what to do. Gerald, monitoring the situation from the islets of Langerhans, noted what the alpha cells were reading. Glucose still present, insulin still quiet, the ratio still favorable, the gluconeogenesis line in Lisa's workshop still running at a steady pace. No emergency. Not yet. Just the ordinary arithmetic of a body that has been awake for 17 or 18 hours and has not eaten for several of them. He had seen it every night of his career. What he was watching for, what he is always watching for in these quiet hours, is the point at which the drift goes from ordinary to significant. The point at which Gary's deliveries and Lisa's production line are no longer quite keeping pace with what the brain and body require. In a healthy system, that point rarely arrives during a normal overnight fast. Gerald and Lisa and Derry, working together, are almost always enough. But it is worth understanding what happens if the drift continues. Because that understanding is the whole reason Gerald exists. If Gloria's levels fall further, the alpha cells increase their firing. Gerald's output rises, Lisa accelerates. And if that is still not enough, if the drift is deeper than a routine fast, then the second tier of the counter-regulatory system begins to stir. Cortisol Carl, who had been running quietly in the background for hours in his proper legitimate role, begins to contribute more actively. His signal to the liver adds another layer of instruction. Make more glucose, use more fat, protect what Gloria remains. And beyond Carl, waiting at the edge of the picture, is epinephrine. The body's true emergency signal. On an ordinary night, epinephrine does not need to act. But it is there, ready, the way a fire extinguisher is always on the wall, even when no one is thinking about it. Gloria drifted. The early warning system whispered. Gerald kept his hand steady on the dial, and somewhere in the liver, Lisa looked at her numbers, checked her supplies, and said what she always said in the quiet hours of the morning. We have order here. That was always Lisa's answer. Not a boast, not a reassurance meant for anyone else's comfort. Just a plain statement of operational fact, delivered the way a night shift foreman might say the loading dock is clear. She had the numbers, she had the supplies, and she had a system that most people, even people who spend a good deal of time thinking about blood sugar, have never fully appreciated. Here is what most explanations leave out. When Glucagon Gerald sends his signal and liver Lisa gets to work building glucose, the glucose she produces does not automatically leave. It cannot. There is a gatekeeper standing between what the liver makes and what the bloodstream receives, and that gatekeeper is a molecule called glucose 6-phosphate. Think of it this way. Imagine you are running a warehouse, Lisa's specialty as it happens. You receive raw materials, you process them, and you produce finished goods. But before those finished goods leave the loading dock, they have to pass through one last checkpoint. The checkpoint decides, does this shipment go out to the rest of the body, or does it stay here, inside the warehouse, for internal use? Glucose 6-phosphate is that checkpoint. It is glucose with a small phosphate tag attached, and that tag matters enormously. A phosphate tag is a kind of molecular address label. It marks a molecule as belonging to a particular location, making it unable to drift freely across a cell membrane. Cells can pass plain glucose in and out. Glucose 6-phosphate stays inside. So when glycogen Gary breaks down stored glycogen, that process Gerald set in motion hours ago, the initial product is not free glucose. It is glucose 1-phosphate, which quickly becomes glucose 6-phosphate, tagged, held inside. Not yet in the blood. The liver has to take one more step. It has to remove that phosphate tag using an enzyme called glucose 6-phosphatase. And here is the part that makes this interesting. Most cells in your body do not have that enzyme. Your muscle cells, for instance, can break down their own glycogen, but they cannot remove the phosphate tag. So the glucose 6-phosphate produced in muscle stays in muscle. It fuels the muscle and goes nowhere else. Muscle keeps its stores for itself. The liver is different. The liver has glucose 6-phosphatase. The liver can strip that tag, convert glucose 6-phosphate into plain, freely traveling glucose, and push it out into the bloodstream, where glucose Gloria can carry it onward to the brain, to the heart, to anyone who needs it. This is one of the reasons the liver is so central to blood sugar regulation. It is not just a storage site. It is the only major organ that can break down glycogen and release the result for everyone else's benefit. The muscle is generous in its own way, but it keeps its glycogen close. Glucagon Gerald understood this well. When his signal traveled down the portal vein and the cyclic AMP cascade lit up inside Lisa's cells, one of the things it triggered, quietly, alongside all the other switches, was a readiness in the glucose 6-phosphatase system. Gerald's signal did not just say, break the glycogen down. It also said, get ready to strip the tags and ship it out. Glycogen Gary, steady as always at his logistics desk since what felt like the beginning of time, had the first pallet ready before Gerald finished the request. But there was something Gary knew, and something Lisa tracked carefully, and something Gerald kept in the back of his mind, even as the hours moved past their quietest stretch. The glucose 6-phosphatase step is not free. It costs the liver a small measure of energy to run every conversion. And the more glucose Lisa pushed out, the more precisely she had to balance her own internal fuel needs against the body's external ones. She was not an infinite faucet. She was a manager. She ran the numbers the same way she always did. How much glycogen remained in Gary's warehouse? How fast gluconeogenesis was building new glucose upstairs? How much glucose 6-phosphate was clearing the checkpoint and reaching the blood, and whether the rate of outgoing shipments matched what the brain and the rest of the body were quietly drawing down. Glucose Gloria, drifting through the bloodstream with her usual quiet industry, was the downstream measure of all of it. When Lisa's output balanced what the body consumed, Gloria held steady, not perfectly still, because nothing in a living system is perfectly still, but within the range that the hypothalamus and the carotid sensors were content to call normal. Gerald's dial stayed where it was. The ratio held. What is remarkable about this whole arrangement, and it is remarkable even if the body performs it without any apparent effort, is how many moving parts have to coordinate perfectly for a person to sleep through the night without their blood sugar wandering somewhere it should not go. The alpha cell reads the blood. Gerald releases his signal. The portal vein carries it in high concentration straight to Lisa. The cyclic AMP cascade throws two switches simultaneously. Gary ships stored glycogen. Lisa's gluconeogenesis line supplements the supply. The phosphatase strips the tag. The glucose enters the blood. Gloria carries it forward. The hypothalamus watches the levels. Gerald adjusts. All of it, every step, running quietly while you sleep. And in the liver, in the middle of that long, dark, industrious stretch of hours, Lisa glanced at the glucose 6-phosphatase readout, made a small note, and went back to running her numbers. Lisa had a saying, not a dramatic one, nothing posted on a wall, nothing cross-stitched on a pillow, just a quiet internal principle she applied every hour of every shift. The saying was this: read the ratio, run the room. The ratio, of course, was the glucagon to insulin ratio, Gerald's signal versus Ivan's, the liver's one true operating instruction. And what most people do not realize, what nobody really stops to explain, is that this ratio does not just tell the liver what to do next. It determines which version of the liver is even running. Here is what that means. The liver is not a warehouse with one door. It is a warehouse with two doors, both installed on the same wall, facing each other. One door opens inward. Glucose goes in, gets tagged, gets stored. The other door opens outward. Glucose goes out, stripped of its tag, shipped to the blood. That is glucagon's door. And here is the remarkable part. The liver cannot run both doors at the same time. Not fully. When insulin is high, after a meal, when Ivan is busy making his rounds, the inward door swings wide. Glycogen synthase, the enzyme that builds glycogen chains, is active. Glucose 6-phosphatase, the enzyme that strips the tag for export, is quieter. The liver is in receiving mode. It is taking everything in. But when the ratio tips, when Gerald's side rises and Ivan's side falls, as it does through the long hours of a fast, the liver does not just slow down the intake. It runs the switch in the other direction entirely. Glycogen synthase gets phosphorylated and goes quiet. And glucose 6-phosphatase, that crucial gatekeeper from the last chapter of this story, steps to the front of the line. The liver switches modes. Not partially, not reluctantly, it commits. Liver Lisa, for her part, described this as simply being professional. You read the room, she would say. You run the operation that the moment requires. The moment requiring it right now was somewhere deep in the long, dark stretch between dinner and dawn. Gloria had drifted low and quiet, not alarmingly so, not to the point where Carl needed to radio in at full volume, just a gentle, sustained softness in the blood. The hypothalamus had already noted it. The portal vein had already delivered Gerald's updated instructions, and Lisa, having received the ratio she needed to receive, had committed fully to the outward door. Glycogen Gary was still at his desk, still shipping. His reserves were thinner now than they had been at the start of the shift. But he had not yet raised a concern. Gary did not raise concerns until he had numbers to back them up. He had the numbers. He would raise the concern when the numbers earned it. Meanwhile, the gluconeogenesis line was running steadily. Alanine arriving from muscle, lactate cycling in through the Cori route, glycerol arriving from the fat stores Gerald had unlocked hours ago. Lisa was building new glucose from raw materials, stripping each finished molecule of its phosphate tag and pushing it out into the bloodstream, one careful unit at a time. And Gloria, quiet, patient, doing her best to stay useful, felt the supply arrive. Not a flood, a steady, even delivery. Enough. What is worth pausing on here, just for a moment, is how precise this switching mechanism actually is. Because it is easy to imagine the liver as a simple responder. Gerald calls, Lisa acts, glucose arrives. But the dual switch is more elegant than that. The same molecular cascade that activates glycogen breakdown also deactivates glycogen synthesis. Protein kinase A, triggered by the cyclic AMP surge that followed Gerald's arrival via the portal vein, does not just flip one lever. It phosphorylates multiple proteins at once. Glycogen phosphorylase, the breakdown enzyme, gets activated by phosphorylation. Glycogen synthase, the building enzyme, gets inactivated by it. One messenger, two opposite effects, delivered simultaneously. This is how biology avoids running a heater and an air conditioner in the same room at the same time. It links the switches together. When one goes on, the other goes off. Not because the liver is cautious, but because the liver is efficient. Lisa would simply call it good management. Running both at once wastes resources. You pick a direction, and you go. There is a word for this kind of linked opposite regulation: reciprocal control. One signal activates one pathway, while simultaneously inactivating the competing pathway. Glucagon triggers it on the breakdown side. Insulin triggers it on the storage side. And the ratio between them determines, at every moment of every hour of every fast, which direction the reciprocal switch is pointing. That is the oh so that is how that works moment of this particular hour. Not that the liver stores glucose, and not that it releases it. Most people have heard both of those facts in isolation. The revelation is that it cannot truly do both at the same time, and that a single molecular signal tips the whole apparatus from one mode to the other. Read the ratio, run the room. Lisa made a small adjustment to the gluconeogenesis rate, noted the glycogen inventory that Gary had quietly submitted, and moved on to the next item on the list. There was always a next item. There was always another number to check, another pathway to manage, another hour of the fast still left to go. There was always a next item. There was always another number to check, another pathway to manage, another hour of the fast still left to go. And somewhere around the deeper hours of the fast, something shifts. Not dramatically, not with any announcement, just a quiet change in the way the body is running its books. Glucagon Gerald had been at this long enough to recognize the moment. It came every time a fast stretched past a certain length. The glycogen reserves, though never fully gone, were well past their peak. Gluconeogenesis was running steadily, pulling in amino acids and lactate and glycerol and assembling them into fresh glucose, one careful molecule at a time. But the liver Lisa, the body's most overworked department head, had also begun to do something else. Something that most people, if they heard about it at all, never quite expected. She had started making ketones. Now, ketones have a complicated reputation. They get talked about in diets and supplements and headline-chasing articles that are not always careful about the details. But here, in the quiet of a plain, ordinary fast, no special diet, no unusual intervention, just the simple fact of not eating through the night. Ketone production was a completely normal and rather elegant part of how the body keeps its energy supply running. Here is how it works. When Glucagon Gerald raises the glucagon to insulin ratio, he does not only signal the liver to release glucose, he also unlocks the flow of fatty acids. Those fatty acids travel through the bloodstream and arrive at liver Lisa's mitochondria, the small power-converting compartments inside her cells. And inside those mitochondria, under the right conditions, the liver does not burn all of those fatty acids directly for its own energy. It processes some of them into smaller molecules, acetoacetate, beta-hydroxybutyrate, and a small amount of acetone. Liver Lisa, characteristically understated about the whole operation, would simply note that she was running a parallel production line. Glucose from gluconeogenesis for the bloodstream. Ketones from fatty acid oxidation, also for the bloodstream, and from there for whoever needed them. And that is the point. Ketones are fuel, not a symptom, not a problem. Just another form of energy currency that the liver manufactures and ships out when glucose supply is lower than usual and the body needs to keep certain demanding tissues running. The brain is the clearest example. The brain is particular about its fuel. Unlike muscle, which can run on fatty acids directly, the brain cannot use fatty acids in any significant amount. It prefers glucose, and in ordinary waking life, glucose is nearly all it runs on. But the brain can use ketones, not perfectly, not entirely, but substantially. As a fast extends and ketone levels gradually rise, the brain begins to draw on them as a supplemental energy source, easing the demand on the liver's glucose production. Glucagon Gerald appreciated this more than most. Every molecule of glucose the brain could spare by running partly on ketones was a molecule the liver did not have to manufacture. It was, in a very real sense, the body rationing intelligently, not through deprivation, but through diversification. Glucagon Gerald, running his logistics operation from the liver's glycogen reserves, had seen this transition many times. The glucose shipments kept going out. They did not stop. But each shipment could be a little smaller when ketones were also in circulation, doing part of the work. Gary found this arrangement entirely sensible. He had been in the business long enough to know that any operation that diversified its supply chain was an operation that lasted. And glucose Gloria, the molecule at the center of all of this, was for once not being asked to be everywhere at once. She was still in the blood, still being dispatched to the tissues that needed her most. But there was a kind of relief in the system, a slight easing of the total demand when ketones were available to take some of the load. She got a little quieter, not absent, not dangerously low, just steady, running at a measured level that the counter-regulatory system was perfectly calibrated to maintain, not with a grand command, but with a shift in ratio. The rising glucagon to insulin ratio did not just flip the liver's glycogen switch. It tilted the entire metabolic landscape. Glucose production on one side, fatty acid oxidation and ketone output on the other, and held them in a balance that the fasting body could sustain across the remaining hours until morning. This is the part that most explanations of glucagon leave out entirely. They say glucagon raises blood sugar, and that is true as far as it goes. But Gerald's real job is broader than that. He is not just the sugar raiser. He is the overnight fuel coordinator, managing the transition from a fed state running on glucose to a fasting state running on a mix of glucose, fatty acids, and ketones, keeping every tissue supplied and every pathway running at just the right pace. Pancreas Pete, if asked about this, would simply say what he always said. Same organ, opposite shift. But the shift was doing considerably more than it looked like from the outside. The body, deep in its fast, was running a remarkably sophisticated operation. And Gerald, calm, competent, quietly tired in the way of anyone who has worked enough long nights, was coordinating all of it. The body, deep in its fast, was running a remarkably sophisticated operation. And Gerald, calm, competent, quietly tired in the way of anyone who has worked enough long nights, was coordinating all of it. And so the deep hours settled in. Not with urgency, not with alarm, just with the quiet hum of a body that knows what it is doing. Gerald was still at his station in the Islets of Langerhans, those tiny scattered communities inside the Pancreas, no bigger than a grain of sand each, but doing the most important work in the building. He had been here since before the last meal faded. He would be here until morning. This was the shift he had always worked. Out in the bloodstream, glucose Gloria moved at a calm, measured pace, not low enough to trouble anyone, not high enough to need Ivan's attention, just right, the way she liked it. She had drifted a little earlier in the night, the way she always does when no food is coming in. A natural, gentle drift, the kind that Gerald reads not as a crisis, but as a cue, his signal to lean forward quietly and begin. And he had. Over in the liver, Lisa was running her familiar overnight operation. She had heard Gerald's signal. She had read the ratio, glucagon rising, insulin quiet, and she had switched the whole apparatus over without a word of complaint. Storage off, release on. That is how she works. One ratio, one decision, no hesitation. Gary had been ready before she even asked. He always is. His amber gold branches had unfurled steadily through the early hours, parcels of glucose dispatched one by one into the bloodstream. He would not call it heroic. He would call it logistics. And when Gary's stores began to thin, as they always do, as they always will, because glycogen is a reserve, not an endless one, Lisa had simply shifted over to the slower work. Building new glucose. Assembling it piece by piece from the raw materials her supply chain had delivered, amino acids carrying their quiet cargo, lactate cycling back through the Cori loop, glycerol freed from fat. A patient operation, an ancient one the body has been running every single night of your life, without ever asking for permission or praise. And alongside all of that, gently, without fanfare, the ketones. Lisa's mitochondria had been producing them in the background. Those small fuel fragments that the brain could use when glucose ran a little leaner than usual. A supplemental supply. Just one more way the body covers its bases while you sleep. Carl had been nearby, professional, punctual, doing exactly what a counter-regulatory deputy is supposed to do, lending quiet support to Gerald's work, reinforcing the slow climb of glucose back toward balance. He did not need to say anything. He rarely does. He just showed up, on schedule, and helped. Ivan, meanwhile, was resting. His delivery route would open again with the first meal of the morning. His crystalline hexagonal shape, that compact blue-gray cluster, was still and quiet for now. He and Gerald were two ends of one dial. One goes up, the other settles. It has always been that way. Neither of them needs the other to disappear. Same organ, opposite shift. Pancreas Pete, warm and ivory pale, his tadpole shape resting in the soft quiet of the abdomen, held both of them, both shifts, both missions. He had been doing this longer than anyone could quite remember, and he would keep doing it with the same tired, steady calm that has always been his way. All of it together, Gerald and Gary, Lisa and Gloria, Carl waiting in the background, was one single, coordinated answer to a simple question. The question the body asks every night, in its own quiet language, without waking you to ask it. Is there enough fuel to make it to morning? And the answer, almost always, is yes. Not because of luck, not by accident. Because of a system so precise, so layered, so elegantly balanced, that it has been answering that question correctly, night after night, for longer than any of us has been alive to notice. Gerald noticed. He always does. That is the job. The night grew quieter still. The body breathed. The liver worked its slow, steady work. Gloria drifted along in the dark, even and calm, held in her range by a system that never sleeps, even when you do. And Gerald, in his small corner of the Pancreas, let out the kind of quiet breath that a person lets out when things are, for the moment, going exactly as they should. Morning was still a little way off, but the night was doing what the night is supposed to do. Holding steady, keeping watch. Holding steady, keeping watch. The night has grown very deep now. This is the hour when the world outside is as quiet as it ever gets. No traffic, no voices, just the slow, dark hush of the small hours before dawn begins to think about arriving. And inside the body, something remarkable is still happening. Not loudly, not urgently, just steadily, the way a good fire holds its warmth long after the last log was laid on. Glucagon Gerald is still at his post. He has been here all night, calm, unhurried, doing the quiet work that most people never think about, because most people are asleep when it happens, which is, of course, exactly right. Gerald does not need an audience. He never has. The alpha cells in the islets of Langerhans, those tiny islands of tissue scattered through the pancreas, they read the blood. They sense what is needed, and Gerald answers. That is the whole job, reading the signal, answering it. Across the way, Insulin Ivan is still quiet. His side of the dial is low. The last meal was hours ago, and there is nothing new coming in. Ivan is resting. Not gone, just still. And because Ivan is still, Gerald's side of the ratio holds its gentle rise. The glucagon to insulin ratio, that quiet number the liver watches, not one hormone or the other, the balance between the two. Liver Lisa has been reading that number all night. She does not need to be told twice. She never needs to be told twice. She runs the numbers herself, quietly, in the dark, and she keeps the line open. Glucose flowing out, steadily, gently, enough. And Glucagon Gerald, the night shift manager of the glucose warehouse in the liver. Gary has been shipping parcels of fuel all this time. Branched chains of stored glycogen, broken down link by link, tagged with that phosphate marker, then stripped clean by Lisa's glucose 6-phosphatase, released into the blood as free glucose. Gary has been at his desk since well before midnight. He does not require reminding. He does not require a second request. Alongside Gary's work, Lisa's gluconeogenesis line is running, building new glucose from the raw materials the body provides. Alanine, arriving quietly from muscle. Lactate, cycling back through the Cori cycle from cells that have been working. Glycerol, released from fat stores that Gerald helped open earlier. New glucose, built from pieces, slow and steady. A different kind of supply chain from Gary's warehouse, but no less reliable. And deeper still, in the mitochondria where the most careful work happens, Lisa has been producing ketone bodies, acetoacetate, beta-hydroxybutyrate, supplemental fuel for the brain, easing the demand on glucose so that every molecule Gerald coaxes out of storage can go exactly where it is needed most. Fuel from 3 directions at once. Glucose from glycogen, glucose from new construction, ketones from fat. Gerald coordinating all of it without fanfare, without a single alarm. Cortisol Carl is nearby, quiet at this hour. Professional. He showed up when the fast deepened, as he always does. The counter-regulatory deputy, steady and punctual. He is not the main act here. He has never needed to be the main act. Carl is simply present, as backup should be, doing his part without drawing attention to it. And Glucose Gloria herself is drifting gently through the bloodstream. Not anxious, not piling up, not too low. Just steady, the way she is supposed to be at this hour, held in range by a system that has been practicing this balance for a very long time. The hypothalamus is listening. Those glucose-sensitive neurons monitoring the slow drift, sending quiet signals back through the network. Nothing alarming, just a continuous, gentle accounting of where things stand. Everything is accounted for. Pancreas Pete, the calm and tireless manager of the whole operation. Wide-headed, pale ivory, never quite off the clock, Pete is aware. Both shifts, both hormones, both sides of the dial. He holds it all. Same organ, opposite shift. That is what Pete would say if he were the kind of manager who said things. Mostly he just keeps going. The body does not panic at a low, it directs it, quietly, precisely, with exactly as much response as the moment requires, and not one measure more. That is what all of this is. A correction, running itself. Gerald holds his post in the deep hours. The warehouse ships its parcels. The factory runs its slow production line. The backup stands ready. The blood holds its steady course. And somewhere in the body, in every quiet cell, in every slow breath, the work continues. Holding, watching, steady. And so the hours have passed, not with drama, not with emergency, not with any of the alarms the body keeps stored, but rarely needs to sound. The hours passed the way a good night's work always passes, steadily, quietly, without fanfare, one small correction following another. One signal answered before the next one was asked. Glucagon Gerald is still at his post. He has been here since before midnight, since the last of Ivan's delivery runs wound down, and the glucagon to insulin ratio tilted gently in his direction. He has not left. He does not leave. That is the nature of the night shift. You stay until the work is done, and the work is done when morning comes. Glucagon Gerald made the first shipments hours ago, moving carefully through the liver's dispatch system, releasing stored glucose parcel by parcel into the bloodstream. Gary did not require a second request. He never does. Liver Lisa held the whole operation together. She read the ratio, switched the molecular apparatus from storage to release, ran the gluconeogenesis lines through the deep hours, built new glucose from amino acids and lactate and glycerol, and when the fast deepened far enough, added ketones to the supply chain as quiet supplemental fuel for the brain. She did all of this without being asked twice. Lisa has heard the 3 a.m. call before. She will hear it again. Cortisol Carl offered his backup, professionally and on schedule, the way he always does. He is not the villain people sometimes make him out to be. Here, in his correct form, he was simply the deputy who stood behind the first responder and said, "I am here if you need me." Most nights, Carl is barely needed. He was barely needed this time. Glucose Gloria drifted a little through the long hours, the way she always does when no food is coming in. She got quieter, not alarmed, just waiting, the way you wait for a bus you know is already on its way. The distributed sensors in the hypothalamus and the carotid bodies noticed. They told Gerald. Gerald answered. Gloria steadied, and insulin Ivan slept. His hexagonal shape still, his delivery rounds finished. He will be called again at breakfast. He knows this. He is not worried about it. The dial between them, that quiet, elegant ratio, held the whole balance through the night. Not one hormone ruling alone. Two ends of one dial. Same organ, opposite shift. Pancreas Pete, that calm and overworked manager with his tired and steady smile, kept both of them running all along. This is what the body does while you are nowhere near conscious of it. It monitors, it adjusts, it builds, it releases, it protects. While you sleep, Glucagon Gerald is already at work. His alpha cells are reading the blood. The ratio is tilting in his favor, and Liver Lisa is building fresh glucose from whatever raw materials the overnight supply chain provides. The brain receives what it needs. Gloria steadies. The whole system hums along in the dark, as precise as it was on the very first night it ever ran. You don't have to do anything. Your body knows exactly what to do. It has been doing this work for your entire life, every single night. So let it, trust it. And as you drift deeper now, Glucagon Gerald will be here when you wake up. Quieter, calmer, better. Sleep well.